Hey guys, and welcome to another video. So last class, we started writing proofs on our even and odd numbers. Today, we're going to take a step back and do some geometric proofs and showing how we can stay being generalized and make general claims. Because remember, we do not want to use inductive reasoning in our proofs where we take specific examples and use those specific examples to make a general claim. So in today's model problem, we have come up with an argument to prove the statement will be true for every possible case. Try to articulate what properties you relied on, how you know you could rely on those properties, and how you know your proof will work for every possible case. And the example they have for us is they want us to use that vertical angles are always congruent. So the first thing I'm just going to do, I'm just going to draw some vertical angles. So let's go ahead. Let's call this line AB. And here, let's have this called line CD. So remember, our goal is that we have to stay generalized. I can't just say like, this is 60, this is 120, this is 120, this is 60, and like, boom, I just proved vertical angles are congruent because 120 is equal to 120 and 60 is equal to 60. But no, that proof only works for when your angles were 120 and 60. It wouldn't really work for any other because you used a very specific example. So let's remain generalized. So to remain generalized, I'm going to call this, oops, let me draw that line back. I'm going to call this angle 1. All right. I'm going to call, oh, there we go. Sorry, it's loading. I'm going to call this angle 1. Let me use a different color so we don't get confused. I'm gonna call this angle 1. I'm gonna call this angle 2. I'm gonna call this angle 3, and I'm gonna call this angle 4, okay? And because I'm not giving them specific values, this is how I'm still remaining generalized, right? So remember, our goal is to prove that angle 1 is equal to angle 3, or angle 2 is equal to angle 4. That is our goal. And you should always have your end goal in mind when you're writing a proof. So how can I begin? So one thing I know right away is that I could say that angle 1, why is this not working with me today? Oh, there we go. I can say that angle 1 is plus angle 2 equals 180 degrees. And I know that is true because line AB is a straight line, and the measure of a straight line is 180 degrees. So that is an example of using a math property to help create your proof. So already I have that angle 1, right? So then with that being said, I could also say the same about angles 2 and 3. And the reason why I'm going to use angles 2 and 3 and not angles 1 and 4 is because I'm going to try to start comparing angle 1 to angle 3. That's the route I'm going to go, right? So I'm going to get angle 3 involved into our proof. So I'm going to do the same thing. I'm going to say angle 2 plus angle 3 is equal to 180 degrees, and it's going to be for the same reason above. But this time we're talking about line CD, right? So let me just move this down a little bit. Oops, sorry. Let me just move that down a little bit because we're going to need more space. So now we did something very important, right? We said angles 1 and 2 equal 180 degrees, and angle 2 plus angle 3 equals 180 degrees. And because of that, we're able to say angle 1 plus angle 2 is equal to angle 2 plus angle 3, right? Because they're both equal to 180 degrees, we can say they're equal to each other. So let me just write that. Because they are both equal to 180 degrees, we can say they are equal to each other. So once again, if you're going to use some math properties, you always have to say why you're able to say that. So remember, the stuff that I'm writing in black are what's, and what I'm writing in red is why we're able to say those what's. So now think about it. Remember, our goal is to say angle 1 and is equal to angle 3. And I'm noticing on both sides of those equal signs, we already have that angle 1 and we already have those angle 3. So all I'm going to do is subtract angle 2 from both sides of that equal sign, right? So if I was just to subtract angle 2 on both sides, we will end up getting that angle 1 is equal to angle 3. Thus, vertical angles are equal to each other. And then you could use this very same argument if you wanted to go the route of proving that angle 2 is equal to angle 4. So once again, let's just recap. We knew that we couldn't use specific values in this. So we kept it general. We just called them angles 1, 2, 3, and 4. Then from there, we had to use a combination of some math rules and properties to get to our end goal of proving vertical angles are equal to each other. And you should always have that end goal in mind. So we just wrote it down right away. We wrote our goal. Then we noticed we was using that, the straight line is equal to 180 degrees, and then doing some substitution, we was able to get there. So you're going to go ahead and do this as well. For this time, you're going to prove that if two parallel lines are intersected by a transversal, that the alternate exterior angles will be congruent. So I'm going to go ahead and provide some math rules and properties you may want to utilize in this proof, but it's going to be your job to figure out in what order you're going to have to use them. So good luck, guys, and get ready for a debrief.